Hello, my name is Ron Kita, and this will be a short video. Hopefully, it'll be reasonable. The experiment that I'm going to run is on my gravity shielding patent US 8901943. It's a very marginal experiment. This setup is far less than optimal. Uh, what I'm going to do is a bunch of samplings. I was hoping to do 10 and 10 samplings, but in terms of keeping this video under 10 minutes or so, I'm going to see where this goes. Anyhow, the electret that I'm using here is a bit unusual. Uh, it was not made by conventional high voltage DC discharge. It was made by a triboelectric means. That means contact electrification via differential in materials. And what happened is I poured dielectric into here, a chlorobenzene material, a binary, and I poured it into here, and I was weighing it, and I just thought, just to see, I knew that there was something, I was aware of the triboelectric effect. In fact, if you search the U.S. Patent Office under Kita, K-I-T-A, U.S. 7340919, you'll catch a refrigeration patent that uses triboelectric means. And what is very significant in that patent that was granted is the triboelectric chart. It's one of the best charts I found. I put it in the patent. And the reason why I wanted to see the voltage source I use to make my electrets my power supply is wall socket based, 110 volts AC. And I wanted to see what a small clean charge would do. And so what happened is I knew when I poured the dielectric into this cavity, I knew that there would be a charging effect. And in fact, on the interior here, it's not available now, but when you see a electrostatic charge develop, the crystals will all cluster to the center, relating a charge. And before I go too far, this one, which I'm going to use for demonstration, when you get a triboelectric charge, you're getting a very, very small charge. And I was not really expecting to see anything. The only difference is this has an open end here, and this has a closed end here. And this cap, this bottom of it, weighs 5 grams, and I was getting very close to 0.05 hundredth on my scale, which would mean a 1% weight change. And this is without any electricity required. This is very marginal, not optimal conditions. I wasn't going to make this, but I see that this is sort of decaying now. There's not much, there wasn't much charge to start with. I want to see if I can get this in here. And there's not almost, there's, yeah, the green light is on. Is there anything on here? There is almost no motion at all in terms of electric charge on here. It's marginal. And with the electrets, they do change their charge over time. They go to zero and come back. But I wanted to film this while there was something interesting, whether it appears that there is some gravitational modification, not large. What you might see is a 0.02 differential. Because when Rhodes, my mentor, Dr. Rhodes, I'll explain it this way. He had a transducer. This is a good example. Let's say it looked like this. It had a backplate on the top, a steel backplate, and it had a thin foil on the top. And he was checking a scale. He was not checking the transducer. He wanted a heavy material, and he knew this transducer was heavy, weighing about 500 grams. And when he took it from one side of the scale to the other side of the scale, he accidentally flipped it over. And what happened is the steel plate was on the top, the dielectric was on the bottom, and the electret dielectric shielded the plate from gravity. When he turned it over, the plate was exposed to the force of gravity and that weighed different. The difference in weight was 14 grams. Here, what you're going to see is, like I said, this is about 5 gram weight on the cap, 0 gram weight here. This is just open air. and I'm going to try to get this on here. This will probably be a short YouTube. Already I'm into 5 minutes on it. So I was hoping to do a sample of 10. This is very repeatable. I've gotten as high as 0.04 hundredths of a gram differential. My goal was to get to 5 hundredths of the gram differential. This is sliding back towards the 2 to 3 gram range, and I want to see what I can film here, and this will be updated and taken down for better for everyone. So I'm going to have to go around back here so I can watch the scale. In terms of the calibration of the scale, this is what I use as my calibration. It's a ceramic coaster, and I'm going to put this on the scale. It's going to weigh about 100 grams. I'm going to tare it to 0. Then I'm going to start flipping and weighing this electret, and you're going to see a different, hopefully you'll see a differential in the weights of it. I have no idea. This has been running good for 10 days, and now it's getting to the end of its life. And like I said, this will be upgraded. And so I'm going to put this on here, go around back so I can see the numbers, what is going on here. Oh, I'm sorry, I got Kelly. I went to a 0. I'll be hitting 0 a lot and just seeing where this goes, and hopefully it will tend to show something. Okay, let's see here. Okay, I'm going to go around back because breathing on the scale will change the weight significantly. What I'm talking about are hundredths of a gram, but we'll see. But like I said, this was getting close to demonstrating 100% gravity modification without any power, nothing, just pure internal electrostatics on benzene ring material. And I found it exciting. Whether anybody else does, I'm not quite sure. So I'm going to go around back here and let's see what I can get here. Oh, I got best put the best see what's. Hopefully this is. Hopefully this will stay here. Okay, so far so good. Okay, I'm going to hit 0 this again. Then I'm going to start weighing this. I might take several samples. I like to run samples of 10 for t-tables for those who want to do the statistics on the probabilities of what the success is. So I'm going to go here. I won't see the screen anymore, and hopefully it'll. Okay, this weighs 0. What I'm going to do is weigh the bottom. This is the bottom. The bottom should be heavier, and when I flip it over, the top should be lighter. Not by much. Hey, this is 8791. Okay, I'm going to say should go back to 8. This is I'm just checking. I'm just doing repeat checks on this. It might take a little while to go back to 81, 8791. I don't want to speed up the scale. Sometimes you have to. I may have to. This should take over. I'm going to start over again. See if I get 81, which is more real. Okay, it seems to be happy at 8790. Just okay. Now I'm going to flip this over, and I'm going to see if it weighs less than 87. Will this weigh lower than 8790? I don't want to rush the scale. Okay, this is about what it runs. It runs about, okay, this is a 2 gram differential. Okay, I'll zero it again. Okay, this is 8791. It's on the margin between 8790. It's coming back to 90. Okay, I'm going to take this off, zero it, and with this on top, I'm going to say this weighs less than 90. It's weighing about 2 grams differential. I'm going to let it sit for a while. Okay, I'm going to weigh on the bottom again. It seems to want to weigh 8790. Let's see if it weighs 8790 again. Okay, I'll let it sit there so I don't interfere with it. Okay, let's see if it weighs less than 8790. Does it weigh less than 8790? Okay, this is what it's running at. I'm going to do it again. See if we get, okay, it's ticked off one. We got 8790, which looks like a good weight. Going to turn this over, see if it's less than 8790. Okay, that should drop down to 88. I've been getting differentials of 3, some as high as 4. And that's about the end of the demonstration. No sense doing it more samples than that. And let me see, I'm going to turn this off here. I'm going to turn this off. And let's see here. Let's see, hopefully this doesn't slide down and crash on me. So that's basically it. There is, like I said, the whole total weight on this was around, starting out, it was around 89 grams. There was some sublimation. The sublimation does result in charging. I don't seal this because by whenever you change from solid or from liquid to solid phase, or if you sublime, you do generate some charge. So in terms of when I set out with this, the initial charges were done triboelectrically. And for information, look at Kita, and it's a refrigeration. It's to improve the performance of refrigerants. There's the triboelectric chart in there. And so this is basically it. So in terms of, I could take more samples, run it longer. It was running as high as 0.4. As I said, when it gets to 0.5, this lid here is 5 grams. So you're talking about 1%. So, I mean, 1%. Bud Clinton, I've got 2% with an elaborate setup. This doesn't have anything like that. I see I'm running at of 12 minutes here. I want to check my notes a second, see if I covered everything, because I will see if I publish this. I will see if it survives. That's it. Okay, 1%. Ron Kita, Chiralex, Chiralex, Chiralex.com, rexresearch.com. If you type in Chiralex, you will get my other videos. This is the 4th video. There's a lot of historic stuff there by Rex. Robert A. Nelson did a great job on it. And 13 minutes. Hopefully it's not burdensome, and that's about the end of the story. I gotta see how I close this thing down here. Let's see.